Jenny had driven for 2 hours at a constant speed when road repairs forced her to reduce her speed by 10 miles per hour for the remaining 1 hour of her 152-mile trip. Find her original speed. So we have one person and kind of two parts of the trip here. So I'm just going to call it first part, second part, just to make it really simple. Bad lines. Bad lines. Now see, I should use that new feature. There you go. Forgot about that. It only does it horizontally. No, it does it vertically too. If you draw a line and hold it, and then you update a notability, it goes straight automatically. I like that for this. Okay, so part one. Jenny had driven for 2 hours. That is a direct amount of time. 2 hours. So her first part of the trip was 2 hours. At a constant rate of speed, when road repairs forced her to reduce her speed by 10 miles for the remaining 1 hour, so the second part is 1 hour, of her 152-mile trip. Now, there's a really, really important word in this question. 2 little letters that make such a difference. It doesn't say it forced her to reduce her speed to 10 miles per hour, but by 10 miles per hour. So there are questions that say reduce it to. So pay attention to the word. They're looking for her original speed. We don't know that. That's what we're looking for. So we're going to make that rate our x. The first part of her trip, she was going x miles per hour. Reduce would indicate that we're going to subtract. And she's reducing by 10, so x minus 10. So again, if it said reduce to, then we would have just wrote 10. Okay? The distance box is always the product of the rate and time. 2 times x is 2x. 1 times the quantity x minus 10 is x minus 10. Then you decide, are they equal or is it a d plus d is total d? So here's Jenny. She's driving along and really going at whatever speed we're looking for. She runs across repairs, and then she's got to keep going, and then finally she stops. So these two pieces together are the 152 miles. So this is going to be a distance plus a distance is a total distance. So 2x plus the distance of the second part, x minus 10, equals 152. Collect your x's. 3x minus 10 is 152. Add 10. 3x is 162. And divide by 3. And you get 54. 54, we look at our chart, represents the original speed she was going, which is what they're asking for. So we don't have to plug anything back in. So 54 miles per hour. That was not quite as challenging as the first one. Question on that one? All right. At 7 a.m., Joe starts jogging at 6 miles per hour. At 7:10, Ken starts off after him. How fast must Ken run in order to overtake him at 7:30 a.m.? All right. So let's set up our chart. We have Joe, and we have Ken. Rate, time, and distance. This time we have a start time from the clock, but we also have an end time for the clock. So we can calculate the exact amount of time. That previous one that we did, we just had, this is when they started. Joe is starting at 7, and we're trying to figure out when Ken's going to overtake him at, we want Ken to overtake him at 7:30. So that means Joe is going to be jogging for 30 minutes, or how much of an hour? Half. Ken doesn't leave till 7:10. He's trying to meet Joe at 7:30, so he's jogging for 20 minutes. 20 minutes is how much of an hour? 1/3 of an hour. It says that Joe is starting jogging at 6. That's Joe's rate. There's only one box to fill in. There's your X. That's what we're looking for, Ken's rate. Distance box, always the rate times time. 6 times 1/2 is 3. X times 1/3 is 1/3 X. Joe and Ken start jogging, 7:30. Ken meets him. We have a distance equal to a distance. So 3 equals 1/3 X. Multiply both sides by 3 to get rid of that fraction. And X is 9. From our chart, X represents Ken's rate, which is exactly what we're looking for. How fast must Ken run? So Ken's got to run at 9 miles per hour. Trying to do something a little bit different on each question. Give you a little bit, like that one you had a clock start and stop time. It takes a plane 40 minutes longer to fly from Boston to LA at 525 miles per hour than it does to return at 600 miles per hour. How far apart are the cities? All right, so we're doing a round trip here. We're going from Boston to LA and then LA to Boston. So I'll set my chart up, B to LA, LA to B. Or you can just put there and back, whatever you like to label it as. They are giving us the rates directly. 40 minutes longer to fly from Boston to LA at 525, so that's my rate from Boston to LA, than it does to return, so LA to Boston is at 600. You have 2 different ways you can put time here. First of all, if it's 40 minutes longer, 40 minutes is how much of an hour? 2/3. And if it's longer, that means we're going to add time. So if, let's do this. Let's see if you can know the difference. Because it doesn't matter where you put your X. It really doesn't matter which one you put your X on. Okay? So if I put my X here, what's Boston to LA? Let me say it. X plus 2/3. 40 minutes longer from Boston to LA. If you put then your x on Boston to LA, then it's going to be x minus 2/3. Okay, so 40 minutes longer to fly from Boston to LA. Okay. Distance is always the product of your rate and time. So 525 x plus 525 times 2/3. I'm using that fraction button a lot. 350. It does not work out 2. And then 600x. So my distance box is always the product of rate and time. So when I multiplied 525, I distributed to my time and got 525x plus 350. Round trip. Going from Boston to LA and then back. Round trip equals each other. So 525x plus 350 equals 600x. Subtract your 525. So I have 350 equals 75x. And once again, I get a repeating decimal. So I'm going to have 14/3. $350 divided by 75, I get a yucky decimal. Do my alpha y equal, or my, yeah, alpha y equals, I said it right. I have written 14/3 up there, so obviously we're having a little issue on a delay here. I knew that was going to happen. Okay, so 14/3 is my x. Now, 14/3 represents the time traveled, or the time it took to go from LA to Boston. What do they want? They want how far apart. How far apart. That is a distance. Oops, I wanted to do a highlighter, not that. That's a distance. So whether you went from Boston to LA or LA to Boston, it doesn't matter. They're the same distance, one way or the other. So go back to one of your distance boxes. This one's way easier. Okay? And we're going to plug in our x value. Okay, so they want a distance, so it doesn't matter which one you use. The easier one would be the better one. So I'm going to take 600 times 14/3. And I get 2,800 miles. always be sure to read the final question so you know what you're looking for.